In the 1960s, as the Cold War spurred hundreds of rapid advancements in military technology, the world's first operational supersonic bomber, the Convair B-58 Hustler, flew ahead of all others. The Hustler pushed the limits of speed with its 4 turbojet engines, achieving Mach 2 at altitudes of 64,000 feet, with the ability to deliver nuclear payloads with precise accuracy. That is, when flown right. Mastering the Convair Hustler proved to be much harder than it seemed. The model demanded the highest skill and focus from its crew, equipped with complex systems that could be as challenging as they were advanced. Isolated in their separate compartments, communication was often reduced to mere hand signals or rudimentary note passing. The faster it went, the harder it was to control, and even small errors could have dire consequences. Despite the razor-thin margin between triumph and disaster, to the Strategic Air Command crews, just attempting to fly this groundbreaking once-in-a-lifetime aircraft was worth it. The Cold War era's endless quest for supersonic flight birthed the Convair B-58 Hustler. The development began with the Generalized Bomber Study, GEB-1, in the immediate post-war period when the United States invited leading aerospace firms to design a bomber that could surpass the sound barrier while carrying a substantial arsenal. By 1952, after rigorous competitive assessments under the renewed GEBO-2 program, Convair's innovative design emerged victorious against proposals from other top contenders like Boeing, North America, Douglas, Curtiss, and Martin. With official approval secured, Convair propelled the B-58 into its maiden flight in 1956. Equipped with 4 General Electric J79GE5 turbojet engines, each providing a thrust of 10,000 pounds force, which increased to 15,600 pounds force with afterburners engaged. This power enabled the aircraft to achieve a top speed of approximately Mach 2, roughly 1,320 miles per hour at altitude, with a service ceiling of about 64,000 feet. In November of that year, in its public debut, the model took off from Carswell Air Force Base in Texas. The aircraft's 38-minute flight, conducted without the use of the external pod or afterburners, captivated an audience of about 30,000 spectators who before this knew relatively nothing of this new model. The following month, the aircraft would achieve its first supersonic flight, complete with the now very recognizable sonic boom, further demonstrating its advanced design and performance. The B-58 Hustler sought to redefine the capabilities of strategic bombing with its Mach 2 flight potential. The name Hustler was coined spontaneously when E. Stanton Brown, an engineering administrative supervisor, heard of the aircraft's impressive performance and replied, quote, "Sounds like it'll really be a hustler." The B-58 Hustler, designed for rapid, high-altitude nuclear payload delivery, showcased groundbreaking advancements in aerospace technology, particularly in aerodynamics and structural design. The initial challenge was to achieve stability at supersonic speeds. During early wind tunnel tests on the XCF-92A, engineers identified issues with the aircraft's highly swept, narrow-chord wings being unstable. Ralph Schick, a Vultee aerodynamicist, proposed a radical solution that led to the adoption of a delta wing configuration. This change dramatically improved stability and control, proving crucial for the aircraft at peak performance. Although delta wings had been explored during World War II, particularly in German designs, the implementation in the B-58 was distinctly an innovation of Convair, leveraging lessons from earlier projects. The delta wing was essential for its stability and ability to fit within the Mach cone, a three-dimensional shockwave pattern generated at supersonic flight. By ensuring the wings stayed within this cone, airflow over them remained effectively subsonic, minimizing drag and enhancing speed. But the technological innovations didn't stop there. One of the most technical innovations of the model was the area rule, a concept that Convair had first experimented with on the F-102 Interceptor, rarely seen at the time. This design principle, conceived by Nacier's Richard T. Whitcomb, shaped the fuselage to taper in where the wings attached, creating a Coke bottle effect that significantly reduced drag at transonic and supersonic speeds. The Hustler was also notable for its compact dimensions compared to contemporary bombers, measuring 95 feet in length and 57 feet in width. It could carry substantial ordnance, including a single 9-megaton B-53 nuclear bomb or up to 4 B-43 or B-61 nuclear bombs. To support such heavy payloads while maintaining high performance, Convair engineers developed an innovative structural design using a honeycomb sandwich construction. This involved layers of fiberglass honeycomb between aluminum panels, all bonded together with heat-resistant adhesives to form the aircraft's wings, ensuring a combination of high strength and low weight, essential for the aircraft's fuel capacity. Incorporating these advanced technologies instead of a bomb bay, the B-58 also featured a unique external pod system that allowed for flexibility in carrying additional fuel, weapons, and equipment. However, this modular approach posed design challenges as changes to the airframe often necessitated modifications to the pod's configuration, complicating the design and testing processes. One of the most unique aspects of the Convair B-58 Hustler was its crew configuration. The model's complex operations required a crew of 3, a pilot, navigator, and defense systems operator, each housed in their own separate cockpit in a tandem arrangement along the aircraft's fuselage. Because of the isolation, the crew had no physical contact. Communication among the crew members was facilitated through an intercom system, and for emergency communication, a string and pulley system and even sign language were sometimes used. For the more stressful moments of an operation, the Hustler had a special companion in the form of Sexy Sally, a female automated voice warning system that alerted the crew to various flight conditions and potential emergencies, as it was believed that a woman's voice would stand out against the cockpit noise and make it easier for the crew to notice and react. The B-58's dependence on speed for defense introduced substantial hazards for the 3-person crew, as conventional ejection at high velocities could be fatal. To address these dangers, the Hustler incorporated a sophisticated ejection system where each person had an ejection capsule that ensured safety within a clamshell enclosure. This advanced system, capable of ejecting at an altitude of 70,000 feet at up to Mach 2, came with an attached oxygen cylinder, enabling the pilot to control the aircraft up until ejection. Once deployed, the clamshell could serve as a life raft, providing critical survival support post-ejection. Despite its advanced technology, the Convair B-58 Hustler faced a significant challenge: its limited range. As a bomber designed during the Cold War to deliver nuclear payloads over long distances, having a substantial range without the need for refueling was crucial. However, the B-58's high-speed performance led to rapid fuel consumption, requiring frequent mid-air refueling for extended missions. This limitation increased the risk of exposure to enemy defenses and sparked debates within the Strategic Air Command about the bomber's operational efficacy. The type's entry into the SAC arsenal was nearly jeopardized as it faced potential cancellation multiple times during its development. Innovations in aerial refueling techniques did extend its operational reach, yet doubts remained about the practicality of an aircraft so reliant on refueling. Moreover, the B-58's development and testing phase was fraught with challenges, including the loss of 5 of the first 20 aircraft to issues ranging from structural stress to unexplained incidents. Such a high accident rate fueled concerns that the aircraft was rushed into production prematurely. Despite skepticism from some quarters, including SAC Commander Curtis LeMay, who favored a new design, the project received staunch support from Major General Albert Boyd, commander of the Air Research and Development Command. He advocated for the bomber's advanced capabilities in a progress report, stating, quote, "The B-58 is a major advance considering that we are attempting to more than double our speed capabilities. For that reason, I believe that it has a place in the Air Force inventory. Since we are attempting such a major advance, there is very naturally a high degree of risk." On October 15, 1959, the Convair Hustler proved naysayers and skeptics wrong when a model sustained speeds greater than Mach 2 for over an hour, covering 1,680 miles in only 80 minutes and with 1 refueling. Finally, the B-58 was officially integrated into the Air Force the following year. Should the Cold War turn hot, her role within the service was to cruise just below the speed of sound, accelerate beyond Mach 2 at altitudes exceeding 50,000 feet, and strike targets up to 500 miles away before returning to base. At the time the B-58 entered service, adversaries were still developing effective surface-to-air missile systems and high-altitude supersonic fighters. This allowed the Hustler to execute missions with minimal resistance and optimal efficiency. During the early 1960s, the B-58 fleet broke numerous speed and distance records in aviation, earning prestigious awards including the Harmon Trophy, the Mackay Trophy, the Thompson Trophy, the Bendix Trophy, and France's Blériot Cup, thanks in part to strategic aerial refueling. To enhance operational safety, Convair and the Air Force introduced the TB-58A, a dual-seat trainer variant that mirrored the flight characteristics of the operational models. The introduction of these trainers significantly reduced accidents among the operational B-58 fleet. Nonetheless, challenges when operating the aircraft persisted. The B-58 was one of the most challenging aircraft to operate in the entire United States Air Force arsenal. Its operations caused continual frustration for everyone involved, from designers to pilots, especially the defense systems operator who managed a complex array of systems within their own cockpit. The Hustler's delta wing configuration lacked horizontal elevators or wing-mounted ailerons. Instead, it utilized a sophisticated system of linkages connecting the wing's elevons, a combination of ailerons and elevators, to the large rudder. The B-58's fuel system was also intricate, requiring vigilant monitoring and adjustment. At Mach 2, the center of lift naturally shifted aft, necessitating a corresponding shift in the center of gravity, which was achieved by transferring fuel to balance tanks. Of the 116 B-58s constructed, 26 were lost, resulting in the deaths of 36 crew members. In June 1961, a B-58 that had previously completed the first supersonic transatlantic crossing from New York to Paris in record time crashed during a French air show. Another serious incident involved a Hustler, carrying 5 nuclear weapons. It slid off the runway at Bunker Hill Air Force Base and burst into flames. While the weapons themselves burned, radioactive contamination was detected in the area for years afterward. The high number of accidents and fatalities associated with the B-58 was likely due to its lightweight frame and rush development, making it more prone to structural failures. While the B-58 Hustler's main defense was its unparalleled abilities, this trait also contributed to its challenges. Despite its remarkable performance, the B-58 was deployed in only 2 operational units. However, once crew members mastered its flight characteristics, it became beloved and highly regarded among Strategic Air Command personnel. According to Navigator Bombardier Ben Badley, quote, "Crews wanted to get in it real bad. It was an airplane careers were made from. Not many people can say they went twice the speed of sound." By 1961, the B-58 Hustler's expenditures had escalated to a staggering $3 billion, around $30 billion in today's dollars. Operating the Hustler proved costlier than other bombers. It required $1,440 per flying hour for maintenance, in stark contrast to the B-52's $1,025 and the B-47's $361. Moreover, for every hour of flight, the B-58 demanded 35 hours of maintenance according to ground crews, underscoring its intensive upkeep demands. Despite initial enthusiasm from its operators, the escalating costs and extensive logistical demands began to fuel doubts about its long-term viability. But most importantly, the technological landscape was rapidly evolving. During the same decade that saw the Hustler's debut, advancements in surface-to-air missiles, high-altitude supersonic fighters, and intercontinental ballistic missiles signaled a shift in strategic military capabilities, ultimately marking the obsolescence of the B-58. By then, speed itself wasn't enough anymore. The final flight of a B-58 took place in January 1970, with the fleet being retired without ever being adapted for conventional bombing roles. Despite its checkered service record, the B-58 Hustler left a lasting impact on the field of supersonic aircraft development, holding records that remain unbroken to this day. Reflecting on the B-58, Ben Badley captured the sentiment perfectly. Quote, "Am I proud to be associated with this great aircraft? You bet your life. Would I do it again in a heartbeat? Was I ever scared? Always.